Hello children, in the previous videos we have seen operations on the sets. We have seen union of the sets and intersection of the sets. See, for your syllabus, difference between two sets and complement of a set is deleted by CBSE. Okay, so only the operations you have to study is union and intersection. So in the last video, what was the union of two set? The set, it contains which and all elements? It contains the element x such that what it was? It is either the element of A or the element of B, or I can say it is the element of both A and B. Okay. So A union B, it contains the element of A or B or of both. So for union, always we use it as either or. So whenever the question it has either or, it is nothing but your union. Okay. Or if you face a word as at least, it is contained in at least one of the set. At least one of the set, that means again what? Either in first set or in the second set or in the both. Okay, so whenever you have at least used, that set is also considered as the union of that two or three sets. Okay, now the next was intersection of the sets. For intersection of the sets, it contains the element x such that if I'm going to find a intersection b, then it contains x such that x is the member of A as well as x is the member of B. I can say x belongs to A and x belongs to B. That is, it is member of both A and B. Okay, so that was for intersection. Now, in this video, we are going to see practical problems on union and intersection of two sets. Okay. So, suppose if A and B are two finite sets. If A and B are any two finite sets, just consider this Venn diagram. Don't see here, don't consider this A minus B or B minus A, because for you it's not there. Just this is my set A and this is my set B. Okay. Now, if A and B are any two finite sets, and if I want to find number of elements of A union B, that means how many elements will I have in its union? Okay, by using Venn diagram, just see how I can. So, number of elements of A union B, that means that element should be in what? That element should be in A or in B. Okay, but that both, that is common elements, we have to take only once. We should not repeat it twice. So see here, suppose if I take here number of elements in A, that is this set. Okay, then again if I take number of elements in B, okay, that means this it will be the set, all the elements in B. Now if you consider whether this portion was counted twice, yes, while counting the elements of A as well as while counting the elements of B. Okay, that means if I want to find number of elements of A union B, what should I do there? It should be number of elements of A plus number of elements of B minus number of elements of A intersection B, because A intersection B part is repeated twice. So one I have to remove it. Okay, and hence you will get here it as, I'll be getting it as number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. Is it clear? Now, next we had seen about your disjoint sets. Yes, what was a disjoint set? A disjoint set was nothing but if the two sets are said to be disjoint only if it has no common element. That means that two sets will be separated sets. Clear? So in that case, what will be my n of A union B, number of elements of A union B? Yes, it will be the figure it will be, this will be my A and this will be my B. Okay. So if I'm going to find number of elements of A union B, will it be number of elements in A plus number of elements in B? Okay. Is there any common thing? No. Because A intersection B is 5. That means number of elements in A intersection B is what? 0. So if A and B are disjoint sets, then we get number of elements in A union B will be equal to number of elements in A plus number of elements in B. Clear? Okay. So this part it is clear? Okay. Now see, the examples are very simple. Now just see, direct examples you will have. If X and Y are two sets such that X union Y has 50 elements. It has 50 elements whether, so can I write number of elements in X union Y is equal to 50? Yes, then X has 28 elements. That means number of elements in X is 28 and Y has 32. That means number of elements in Y is 32. So whether by reading the statement, I can write this and all things. Now what is the question? We have to find how many elements does your X intersection Y have? Okay, see, you have been given number of elements in X union Y, number of elements in X and number of elements in Y. Okay, so can I make use of the formula n of X union Y will be equal to n of X plus n of Y minus n of X intersection Y. Yes, because the three things I have been given, so I can find the fourth one. Okay, so here I'll be getting it as, just substitute the values and I'll be having it as answer of n of X intersection Y, it will be equal to 10. Okay, is that clear? Okay. The next one. In a school, there are 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics, 4 teach both physics and mathematics, then how many teach physics? Okay, now whether how many sets I can have here, whether two subjects are mentioned, maths and physics. Okay, so let M denote the set of teachers who teach mathematics. Okay, it's not that M or P itself you have to take. You can take A or B. Okay, so let M denote the set of teachers who teach mathematics and P denote the set of teachers who teach physics. Clear? Now just see line by line. In a school there are 20 teachers who teach mathematics or physics. Now see, in a school if the teachers are there, then they will teach at least one subject. Okay, there won't be any teacher who won't be teaching any subject. That means at least one subject is handled by the teacher. So that 20 is not your union of the set. 20 is not your universal set. Okay, suppose if just it is given total, there are what we can say, if there are 100, if there was a survey conducted in a city for 100 people and then it was mentioned about teachers who teach physics and maths, because in 100 students, 100 people, each and everyone won't be a teacher. Okay, then in that case your 100 will be the universal set. But here that 20, it will be what? Your union itself. Why? Because here it is the teachers, either they teach maths or physics, or, see the conjunction or. Okay, so my n of M union P is given to be what? 20. See the next statement. It is of this 12 teach maths and 4 teach physics and mathematics. Okay, so 12 teach maths, that means is it number of teachers who teach maths is 12. So n of m is given to be what? 12. And 4 teach both the subjects. That means the teacher is teaching maths as well as she is teaching physics. So whether it is the intersection of both. Okay, so can I say that n of m intersection p is given to be 4? Okay, so this is what is given to you, and what we have to get there, number of teachers who teach physics. That means I have to find n of p. Okay, so again I have been given the three things. I can find the fourth one by using the formula. So use the formula n of m union p is equal to n of m plus n of p minus n of m intersection p. Okay, substitute the values, you will see that n of p it is equal to 12. Is that clear? That means number of teachers who teach physics is 12. Is that clear? Okay. Next one. In a class of 35 students, 24 like to play cricket and 16 like to play football. Also, each students like to play at least one of the two games. How many students like to play both cricket and football? So total how many students are there? 35. Now 24 like to play cricket and 16 like to play football. That means how many games I have? I have the games, that is cricket and football. So you can take, let X be the set of the students who like to play cricket and Y be the set of the students who like to play football. Okay. Now here your 35 is the strength of the class. But is it mentioned that each student likes to play at least one of the two games? That means there won't be any student left behind who will not play any game. Okay? So whether that 35, is it the union of that two sets? Yes, only if it is given that a class of 35 students, 24 like to play this, 16 like to play the second game. Okay, and some do not play any game. In that case, my 35 won't be my union. Okay, since it is specially mentioned that each students like to play at least one. Okay, that means minimum one game they prefer. That means that 35 is nothing but union of the two sets. Okay, so now we will write what and all we have been given. So n of x will be having, that is 24, n of y I have 16, and n of x union y is given to be 35. And what we need to find, how many of them like to play both cricket and football. Both cricket and football means what? It is the set x intersection y. Okay, so if you substitute the value, you will get that x intersection y, it will be equal to 5. So 5 students like to play both the games. Whether this is it clear to you? Okay, now the next video it will be continued with this problems. Okay, hope till this the concept is clear. Okay, thank you.